Alright, let's look at trigonometry function. Trigonometry functions. We have two basic trig functions. We have the sine, we have the cosine functions. Other trigonometry functions are actually the combination of either sine or cos. So at this point, we can generate other ones that are related with sine and cos, and we can relate the to a value of theta. So let's say we are having sine theta and cos theta. The third trig function is tan theta, and tan theta is always equals to sine theta divided by cos theta. We also have the fourth trig function. We call it sec theta. Sec theta is 1 divided by cos theta. We have cosec. Cosec theta is inverse of sine theta. We have the fifth function of trigonometry to be cot theta. Cot theta is the inverse of sine theta, which is the same thing as 1 divided by sine theta divided by cos theta. So at this point, we have cot theta is cos theta divided by sine theta. So these are the basic trig functions that we have that are related with either sine theta or cos theta. We also want to look at some of the identities that we have in the trigonometry ratio. We have that if we have the combination, the addition of cos squared theta and sine squared theta, we add two of them, we are having one. So that is, this is identities. We have number one identity. Number two is this, that we can generate other identities from this. So if we dividing both sides by cos squared theta. So from equation 1, we have cos divided by this plus sine squared theta divided by cos squared theta, and we have 1 divided by cos squared theta. So we have this, we cancel this, we have 1, and we have this divided by this from our own initial relationship. This is tan squared theta, and also this becomes sec squared theta. So we are actually saying that tan squared theta is the same thing as sec squared theta minus 1. So we have that identities. And number 3 identity is of trigonometry ratio principle is given that dividing both sides by sine squared theta. From equation 1, we'll have cos squared theta divided by sine squared theta. You plus with sine squared theta divided by sine squared theta 1. So we are actually going to write this to be cot. This is cot squared theta plus 1. We have to divide these two by sine squared theta. This is giving us cosec squared theta. So we arrive that cot squared theta is equals to cosec squared theta minus 1. That is the third identity. And we also want to introduce what we call special angle. We have special angle in short form. Special angle in short form. We have these special angles. We have angles. We have 0 degrees. We have 30 degrees. We have 60 degrees. We have 90 degrees. We have 45 degrees. So we can actually look for this angle in sine function. Assuming this is theta, sine theta, cos theta, and tan theta. So before we fill our table, we are going to use a special angle, special triangle. We are using special equilateral triangle. We have that the triangle should be this, and having the equilateral triangle, the sides are the same and all the angles are the same. So it means that the angles are 60 degrees, and we also have that the side, we can assume it to be 2. So let's label it. So we can actually have this to be 0.0. We have this to be A, B, and C. We can actually mean that this angle, dividing this into 2, we have 30 degrees Celsius. We have 30 degrees. So this other one is 60 degrees. So we can, having this to be 90 degrees, we can divide this and we have 45. So the aim is to generate the result of all this angle in short form. Starting with the principle of right angle triangle, we should also recall that the sine, if we have a triangle of this nature and we have this angle to be theta, with reference to this angle, this is opposite, this is adjacent, and this is hypotenuse. So we are having that the sine of this angle is actually opposite divided by hypotenuse. We have cos of this angle to be adjacent divided by hypotenuse. And also we have tan of this angle to be opposite divided by adjacent. So if you are making 30° as reference, referring to this triangle, we are actually having that this is 2, this is 2, and this is 1, 1. Because the line BO has divided line AC into 2. So at this point, we are having that sine 30 is actually equals to opposite divided by hypotenuse. So we're having 1 over 2, which is 0.5. The same similar we have cos 30, which is actually adjacent divided by hypotenuse. So, and we did not have the value for BC. Having gone to this stage, we pick the triangle, we draw it. Having drawn the triangle, we have 0B and A. So this is 2 and this is 1. So the size of BO is going to be, according to particular theory, it's going to be this squared minus 1 squared. So B squared, and we have is going to be 3. So B0 is going to be square root of 3. So B0 actually is square root of 3, and cos 30 is equals to opposite adjacent divided by hypotenuse. So that's why we're having root 3 divided by root divided by 2. So similarly, tan 30 is giving us tan 30 is also giving us opposite, which is 1 divided by root 3. So in this our table, we can actually feel it that the answer for sin 30 is 1 over 2, and for cos 30 is this, and for tan 30 we have 1 over square root of 3. We can do the same with special angle 60, which we are going to make reference to our own special triangle. And in that special triangle, we can refer to this. So having done that, we are saying that sine 60 is actually equals to opposite divided by hypotenuse, which is this over this. We also have cos 60. We have cos 60 is adjacent divided by hypotenuse, and we have this, and tan 60 is also opposite divided by so we have tan 60 to be square root of 3 divided by 1, so tan 60 is square root of 3. So we can refer to our table and feel 60 degree in the special angle respectively to be, this is root 3 divided by 2, this is 1 divided by this, and this is root 3. We can do the same with special angles of 45, which we are referring to the extraction of this special